Joe Smith.
And I'm Amy Smith.
We're going to show you aspects of good research.
I thought we were going to talk about your research.
Oh, very funny, Amy. Anyway, please read this example of good research.
You should push the pause button on your video player, and when you're ready, press the play button to continue.
In experimental research, there's always some type of comparison or control group. With that one here, you would not know whether herbal supplements actually improve memory. The article states that there is a control group.
In other cases, the wording might not be as direct, so be aware of that. And I should add that in correlational research, there is usually no comparison or control group because the experimenter usually doesn't manipulate anything. In correlational research, the goal is to look for associations rather than causal connections. You will also want to keep that in mind.
Good point, Amy. The participants or subjects should be randomly assigned to the different conditions.
This is an easy way to make sure that groups are similar to one another at the beginning of the study.
Right. The dependent variable, what the researcher measures, should be accurate, precise, and sensitive.
An accurate measure is one that is as close as possible to a true value.
And a precise one uses units that are small enough for what you are studying.
Like inches rather than feet for measuring someone's height.
Nice example. A sensitive dependent variable is one that can show the effect of the independent variable. What the experimenter typically manipulates.
Like the type of food.
Right. If a dependent variable, let's say a test, is too easy, then all the scores will be at the top, all the same.
And if it's too hard, then they would all be near the bottom.
When a dependent variable is sensitive, you can see differences, if they truly exist.
I should point out that if there are no differences, it does not necessarily mean that the measure lacked the appropriate amount of sensitivity, but you should consider that possibility.
But in this write-up, there were differences, so sensitivity is not an issue. And because the times were recorded in milliseconds, they should be also accurate and precise.
Nice observation, Joe, but sometimes I wish you were more sensitive.
Not now, Amy. The dependent variable should also be scored objectively. Here, a computer measured the running times, which is very objective.
Because it doesn't require any human judgment.
The dependent variable should also be valid. The time to run a maze is a valid measure of memory and rats.
Also, participants in psychology experiments should not bias the results. When they do, it is called subject bias. I doubt that the rats bias these results.
In good research, there is little or no attrition or mortality. That is when subjects either drop out of the study or when they die.
Ooh.
When there is attrition or mortality, the results can be biased because the subjects who dropped out or died could have had very different responses than those who remained.
However, in this case, all rats remained in the study, so there was no attrition.
Also, there should be an adequate sample size. In this case, there were a total of 80 rats, which is pretty good.
Although an adequate sample size depends on a number of different factors, sample sizes which fall below 20 per condition would be cause for concern if the results showed no differences between groups.
And that's a nice rule of thumb. Good research usually describes sample selection or how they got the sample of participants or subjects.
In this example, the rats came from a colony used by the university. Pretty standard.
Also in good research, the experimenter does not affect the data. When this occurs, it is called experimenter bias.
I don't think it happened here because the researcher, Dr. Samuels, had no ties to the herbal industry which would want their herbal supplement to work, so I doubt that she was biased.
You are on today.
Well, let me continue. Also in good research, there is usually some acknowledgement of whether more data or research is needed to make a strong claim about the findings. So often research says something about how the results will or will not generalize to other participants, settings, and laboratories. Here, Dr. Samuel states that the results might not apply to humans.
Lastly, correlation does not mean causation. So, it is important that in correlational research, the researcher does not imply causation.
But this is not a problem here because this is not a correlational design. It is a true experiment.
Well, that's about it. I'm Joe.
And I'm Amy.
And these are aspects of good research.